Hi everyone, welcome to Project Rosalind. If you're new to Project Rosalind, we're a student-led organization that aims to promote science education for elementary and middle school students. You can find out more about us at our website, projectrosalind.weebly.com. In this video, we will be learning about Newton's 3 laws of motion, which are 3 very important laws in physics. Before we get started, please take a moment and visit the Google form link in the description box below to take a pre-video quiz. The results are completely anonymous, and they will help us understand how effective our videos are. Let's get started. Newton's 3 laws of motion were first thought of by Sir Isaac Newton, an English physicist and mathematician, and he wrote about these 3 laws in 1687 in his book called Mathematical Principles of Natural Philosophy. His first law of motion is also known as the law of inertia, and it says that if an object is in motion or at rest, it will continue to stay in motion or stay at rest as long as the net force on that object is 0. For example, if you put a box on the ground and you left it there, it would stay at rest and not move until a force, like if someone pushed it, acts on it. Another example is if you have a ball that's rolling. Theoretically, the ball will keep on rolling in the same direction until a force acts on it, like if the ball is kicked in the opposite direction. Of course, we know that this only works in theory, but not in real life, because if you've ever rolled a ball, you know that it eventually comes to a stop. That's because some of the ball's energy is lost because of friction. But once again, in theory, the ball should keep on rolling forever. An important concept that has to do with this law is the idea of net force. Net means the sum. So based on Newton's first law, if the sum of all the forces acting on an object is 0, then the object will continue staying in motion or stay at rest. Let's practice this idea with a few questions. But before we start, here's a fun fact. Force is measured in units called newtons, which are named after Sir Isaac Newton himself. Alright, here's our first question. If we have a box that is at rest, and 5 newtons of force are pushing it left, and 5 newtons of force are pushing it right, will the box move? Well, the net force is 0 newtons, so the box will stay at rest. Now, what if we had the same exact box, but instead there are 5 newtons of force pushing right, and only 3 newtons pushing left? What happens now? This time, the net force is 2 newtons to the right. Since the net force now is no longer 0, the box will not stay at rest and will start moving to the right. With that, let's move on to Newton's second law of motion, which states that the magnitude of a force acting on an object is equal to the mass of that object times its acceleration. To simplify all of that, we can write the second law as an equation, F equals ma. This explains why it takes so much more energy and force to move a heavy object compared to a lighter object. For example, if I had a bowling ball that had a mass of 5 kilograms and a tennis ball with a mass of 0.05 kilograms, it would be harder for me to move the bowling ball. That's because it takes more force to accelerate the 5 kilogram ball, since it has more mass. Finally, Newton's third law of motion says that every force will have an equal and opposite reaction force. In other words, if object A exerts a force on object B will exert an equal and oppositely directed force back on object A. It's important to remember that pairs of action and reaction forces act on different objects. So in the previous example, one force acted on object A, and the reaction force acted on object B. Let's dive into a more concrete example of Newton's third law that has to do with gravity. When we stand on Earth's surface, gravity pulls us down towards the center of the Earth. The reaction force for this is that we exert an equal and opposite force on the Earth. Now, some of you guys are probably wondering, why doesn't the Earth accelerate upwards if we exert an upward force on it? To answer this question, we need to use Newton's second law, which, if you remember, says that force equals mass times acceleration. Since the force of the Earth on us and the force of us on the Earth are action and reaction forces, they have to be equal. However, we also know that the Earth is much more massive than a person, so the acceleration of the Earth is much less compared to our acceleration. This explains why we have an action-reaction pair of forces, even though one of the objects has a greater acceleration than the other. So today, we explored what Newton's 3 laws of motion are, and we also went through several examples of these laws. These 3 laws are incredibly important for understanding physics, and they also help explain why forces and the motion of objects are the way that they are. We hope you learned something interesting, and please comment any questions you have down below. Now that you finished this video, please take our post-video quiz linked in the description box below. If you enjoyed this video, please subscribe and turn on notifications. See you next time!